Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 6.2 entitled Trigonometry of Right Triangles. And today we're going to review the 6 trigonometric ratios as well as the special right triangles. Those are going to be our 45, 45, 90 and our 30, 60, 90 triangles. And then we're going to use that information to help us solve a right triangle. So these trig ratios, these 6 trig ratios, we talked about them in chapter 5 as well. You have sine and cosine and tangent. And remember, these ratios are basically a way to help you either find an angle measurement or a side on a right triangle. So if you have an angle, they have it marked here as theta in this triangle. If you're trying to find the opposite or the hypotenuse side, you can use the sine of the angle. Cosine of the angle is equal to the adjacent over the hypotenuse. Remember, the adjacent side is the side next to the angle. Okay, opposite is directly across. The hypotenuse is always the hypotenuse. It's across from the right angle. And then adjacent is the other side that's right next to the angle. And then tangent's opposite over adjacent. So that's the SOHCAHTOA that you've known since geometry. And then we have our inverses as well. We have cosecant, which is hypotenuse over opposite, secant, which is hypotenuse over adjacent, and then cotangent, which is adjacent over opposite. And remember, we also know that tangent is the same as sine over cosine, and that cotangent is the same as cosine over sine. So we know those ratios as well for tangent and cotangent. Okay, and the symbols that we use to abbreviate the names, their full names are listed there: sine, cosine, tangent, cosecant, secant, and cotangent. You know that already. And here we have 2 triangles that are shown. Now remember, a lot of this for the side measurements of right triangles is also based around Pythagorean theorem. So here in this first triangle, you have a leg that's 3 and a leg that's 4 and a hypotenuse that's 5. So that's a 3, 4, 5 relationship. That's called a Pythagorean triple. So any triangle that has a leg that's 3 and a leg that's 4, the other side is going to be 5, as long as it's a right triangle. And the hypotenuse will always be 5. Remember, the hypotenuse has to be the longer side as well. And these trig ratios can be used for any triangle, regardless of their size. Okay, so you could make the triangle a 30, 40, 50. That's still going to be a Pythagorean triple. It's just 10 times bigger than the other one. Okay, so let's find our 6 trigonometric ratios for this triangle. Again, this is kind of review of the 6 trig ratios and what we did in the previous chapter as well. The nice thing about this triangle is that they have all the sides already found for you. In some of your homework problems, you might have to find one of the sides first. Now keep in mind where they're labeling the angle here. This is where our angle theta is. So sine is going to be opposite over hypotenuse, so that'll be 2 over 3. Cosine is going to be adjacent over hypotenuse, so that's the side that's next to the angle. So that's square root 5 over 3. And then tangent is going to be opposite over adjacent, so we have 2 over 3. Oops, nope, 2 over the square root of 5. Sorry, I was looking at it wrong. 2 over the square root of 5. And we can't leave the radical in the denominator, so we have to rationalize it. So it's really going to be 2 square root 5 over 5. And then to find the inverse trig functions, you basically just take the reciprocal of all of these ratios here. So we have the cosecant will be 3 over 2. The secant is going to be 3 over the square root of 5. But again, we can't leave the square root of 5 in the denominator, so we have to rationalize it. So that will be 3 square root 5 over 5. And then we'll have cotangent, which is the inverse of tangent. So I would go back to my original function here. or my original ratio, where I had 2 over the square root of 5, and I would just flip that, so we have the square root of 5 over 2. That saves you time from having to flip your final answer and then rationalize again. Okay, so this type of work we did in the previous chapter as well. This is just a refresher or a reminder to keep in mind that these 6 trig ratios still apply for all the information that we're going to be working with in this chapter as well. And then we still have our special right triangles, and we've talked about these before when we were dealing with our unit circle and finding our terminal points on the unit circle. And basically we have these so that we don't have to do Pythagorean theorem all the time. Okay, the old dead math people made an observation that anytime you have a triangle that's got a 45 and a 45 and a 90-degree angle, the side measurements are going to be such that the legs are both going to be 1, and the hypotenuse will be the square root of 2. Okay, the legs are congruent here because the base angles are congruent. And if you did 1 squared plus 1 squared, it would be equal to the square root of 2 squared. And then for the 30, 60, 90 triangle, okay, they have it drawn in here. It depends on which way you're looking at it. It could be a 30, 60, 90 or a 60, 30, 90. Okay, so depending on how the triangle is situated, you can draw it in a lot of different ways. The 30-degree angle is going to be next to the adjacent side, and that side is always going to be the square root of 3. The hypotenuse is always going to be 2, and then the leg that's opposite the 30-degree angle, that will always be a 1. So it has a 1, 2, 3 sort of mentality to it. That's how I like to think of it. Okay. Notice that the hypotenuse here is 2, and the hypotenuse on the previous triangle had a 2 in it as well, but it's the square root of 2. There's always one side in these triangles that has a square root. Okay. And again, if we took 1 squared plus the square root of 3 squared, it would equal 2 squared. Okay. So again, this information is coming from the Pythagorean theorem. Okay. So here's our 2 triangles again, the pictures of our 2 triangles. And we're going to use these when we're solving problems, if we're solving a triangle or needing to apply a triangle to some sort of real world situation. Okay. And remember that our angles 30 and 60 and 90 are also pi over 6 radians, pi over 3 radians, and pi over 2 radians. Okay. And then this information we've talked about in the past. I believe this is on page 445 in your book. And this is all the same information that we had in our first quadrant in our unit circle. So you've seen this information before of taking the sine and cosine and tangent of all of these degrees, the 30, the 45, and the 60. And that's where we get the 1/2 square root 2 over 2, square root 3 over 2, etc. So again, don't memorize this table of values. It's in your book, so you can reference it if you need to quickly look something up. Okay, but you should know that first quadrant in the unit circle still. Know that it applies to all of the other 3 quadrants. You just change the signs as you go around the unit circle. Oops. And then here again, they have a little reminder of our reciprocal functions. Cosecant, instead of being the ratio with the hypotenuse and the adjacent, you can think of it as 1 over sine. And secant, instead of thinking of that as the previous ratio, you can think of it as 1 over cosine. And cotangent could be 1 over tangent. Cotangent could also be cosine over sine. Okay. So if you're going to put them into your calculator, especially, that's how you have to type them into your calculator. So if you're going to type in a cosecant of something, it really has to be the 1 over sine of something. There we go. Okay. Um, and here they're talking about how you write the sign of 1, for instance, and it depends on the mode that your calculator is in. So if you're taking the sine or the cosine of any number or the tangent of any number, if you're in radian mode, you're taking the sine of 1 radian. So that's going to have a different decimal than if you're in degree mode and you take the sine of 1 degree. So just keep that in mind, that you have to pay attention to what mode your calculator is set in. And as we go through the chapter, we'll talk about when you need to switch from radian mode to degree mode, etc. But again, that you should be familiar with. Okay, and then how we're going to put all this together for problems that are a little bit new, at least for this year or this chapter, is that we're going to solve triangles. Now you've done this before in geometry and in algebra 2, so this should be fairly straightforward. And anytime it says to solve a triangle, that means to find all the missing measurements, I guess. Find the missing measurements. And those could be side lengths, or they could be angle lengths or angle measures. And you can use any of the tools at your disposal. You could use any of the trig ratios, you could do Pythagorean theorem, your special right triangles, doesn't matter. Oops. Okay, so here we have a triangle. It's a 30-degree triangle and a 90-degree triangle, and so therefore this other angle must be 60 degrees. So it's a 30, 60, 90 triangle. And we have to solve for the missing pieces of information. Now, we've already solved for one piece of information. We know that the measure of angle B is 60. You know that in a triangle there's 180 degrees. 180 minus 90 minus 30 will get you 60. Okay. But we still have to solve for side A and then side B. So this is where we're going to use our trig ratios, or we could use our reference triangles. If we're going to use our reference triangle, that might be a little bit faster. So I'm just going to draw the reference measurements, 1, 2, square root 3, for our 30, 60, 90 triangle. So then basically, if we're using this to help us solve for either side A or side B, doesn't matter which one you start with. I'll just pick A, just because it comes first alphabetically. Okay. We're basically going to do a ratio here. The two sides that we know from one triangle to the other are our hypotenuses, or our hypotenuse. Okay, so if I take this reference triangle and multiply it by 6, I get my original triangle from the problem. So if I'm going to find what A is, that has to have a relationship of 1 to A and 2 to 12. So you could set up a little proportion if you wanted to. You could say A is to 1 as 12 is to 2. So then you could cross multiply or divide, or you could just know that A over 1 is the same as A, and 12 over 2 is the same as 6. So A is going to be 6. And once you know that side, once you know the side that is the 1 measurement, I like to kind of call that your home base, because then it's really easy to just multiply that number by whatever else you need to get to the other sides. So if I knew what this side was, I would just multiply by 2 to get the hypotenuse. Or if I know what that one side is, I would multiply by the square root of 3 to get the adjacent side. So that's what we'll do to find part B. I will just take 1, the measurement for this side now, which is A, and I will multiply it by the square root of 3. So A I know is 6. So to find what B is, I'd have to multiply by the square root of 3. So it's just 6 square root 3. And you can leave it like that. That's a simplified radical. I can't do anything more to it unless I plugged it into my calculator and got a decimal for it. Now we could also do this with our trigonometric functions. Okay, so if I wanted to, I could find a by doing opposite over hypotenuse. So that would be sine of 30 would be the opposite over the hypotenuse. Then I'd have to multiply both sides by 12. So 12 times the sine of 30, you should still get 6. And if I wanted to find b, then I would have to do adjacent over hypotenuse. So adjacent over hypotenuse would be cosine. So cosine of 30 would be the adjacent over the hypotenuse. So 12 times the cosine of 30. Now if you do this in your calculator, they're going to give you the decimal, but it's going to be the same decimal as whatever 6 times the square root of 3 is. Okay? So that's another way that you could work through this problem as well. Okay, now we're also going to talk about angle of elevation, depression, and inclination, because these are some good application problems that you'll see for all of this right triangle stuff. Okay, angle of elevation is basically when you look at something, if you look directly towards it, that's called your line of sight. Okay, and then if you look up at that other something, that's your other line of sight. And that change between your two lines is your angle of elevation. Okay. Angle of depression is if you looked straight out and then you looked down at an object. It's that angle that's between where you were looking straight out and where you were looking when you were looking down. Okay, so angle of elevation is the angle between the line of sight and the horizontal. And then the angle of depression is the angle between the line of sight and the horizontal, but this is when you're looking down at an object. Okay, so think elevation goes up, depression goes down. And then there's also angle of inclination. That's when you're following an object. I think they might, oh, no, they don't have a picture of it. But that's when your line of sight follows a physical object. So that's when you're looking up the hillside. You would follow the hillside with your eyes. Most of the time, we see angle of elevation and depression in our word problems, though. Okay. So here's our last example. To find the height of a tree. Now, this is what you could actually use if you didn't have the capabilities to climb to the top of the tree and drop a tape measure all the way down to the bottom. Okay, here we have a giant redwood tree, and it's casting a shadow that's 532 feet long. Find the height of the tree if the angle of elevation of the sun is 25.7 degrees. So that means you've measured the shadow, and then you're standing at the end of the shadow there, and you're looking up at the sun. You'd look straight out ahead of you, and then you would look up. And that angle going up is going to be the 25.7 degrees. That you can actually measure. If you see people out surveying, that's what they're measuring, those angles of elevation and depression. Okay? So we want to find the height of the tree then. So in this picture, you'll notice that you just kind of have to view this as a little bit of a triangle. You've got your height, you've got your base, and then you've got your hypotenuse. And then this is going to be your angle here, theta. So we're trying to find the opposite side, basically. And we know our adjacent side, and we have our angle. Okay, so opposite over adjacent. If you think of SOHCAHTOA, that would be tangent. Tangent is going to be opposite over adjacent. Oops. Okay, so our angle was 25.7. And then our opposite is our height. That's what we're finding. and our adjacent is the 532. That's the shadow. So now we have an equation that we can solve for h. So we have to multiply both sides by 532. Now, I like to put the number that I'm multiplying the tangent by in front, so that way you don't put it behind the number and your calculator accidentally takes the tangent of 52.7 times 532. You don't want your calculator multiplying those two numbers together and then taking the tangent of that huge number. We want your calculator to do the tangent of this angle and then multiply it by 532. So you can type this all into your calculator the way it looks as long as you put that 532 in the front. And then you should get 256.03 feet. Okay. Now that's how you find a side length. Remember, if you're trying to find an angle, like if they had told you what the height was, but hadn't told you the angle, you would be finding the tangent of some angle, let's just call it A, would be the opposite over the adjacent, let's round, 256 over 532. So when you're trying to find an angle measurement, remember this is where in your calculator you have to do the tangent to the -1 and then do the 256 divided by 532. And that should get you the 25.7 degrees. Okay, so when you're dealing with finding an angle, that's when you do the tangent to the -1 or sine to the -1 or cosine to the -1. That's what that is used for in your calculator, to help you find an angle measurement. Okay, so you can test this out, see what answer you get in degree mode or radian mode. This is the correct answer. So if you don't get it in radian mode, then you need to switch over to degree mode. Okay, so I'll let you figure that out. And here are your problems that you'll need to practice these skills. A lot of this should be review. A lot of it in the beginning is review with your 6 trig functions and with your reference triangles, but definitely show some work for that solving of the triangle type questions. Remember, the problems are worked out in the binder in the classroom. All the odds are in the back of the book. And if you have any questions, come on in and see me before school.